Okay, welcome back. This is part 2 for topic 2.3, estimating derivatives of a function at a point in the AP Calc curriculum. We're estimating derivatives. We're going to look at how the derivative point can be estimated from the information given in tables or graphs. We're going to look at word problems, and we're going to use technology to estimate the value of a derivative of a function at a point when given the equation. So let's look over here, and we're going to look at some examples. We looked at graphs when we did the first part of this video, where we showed you if you have the graph of the tangent line, or you can estimate the graph of the tangent line at a point, you can use the slope of that tangent line to estimate the derivative of that point. And then we'll look over here, and whenever we're given tables, we might be asked to estimate, we're looking at this table, estimate, let's say, f prime of 3. Or here we could estimate f prime of 1. Here we could estimate f prime of negative 1. Estimate f prime of negative 3. Now you might see where I'm getting those numbers now, that I'm looking at halfway between entries on the table. We can use the secant line. If we were to plot the points for 2 and 4, for x equals 2 and x equals 4, the point 2, 6, and 4, 3, if we were to plot that on a graph, sorry, wrong pen. It's not broken yet. 2, 6, and 4, 3. Then we could say that a good estimate for the curve, or a reasonable estimate, as very reasonable as we can from this table, for the derivative at f or x equals 3, a good estimate for that would be the slope of that secant line between these 2 points. So here we're going to use the difference quotient to estimate this. We're going to take a point, 2 points equidistant from the x value we want to estimate the derivative at. So we're going to take the difference quotient for the points 2, 6, and 4, 3, and we'll do the y value, f of, well, let's just go ahead and write it out so that you can see that. We'll do f of 4 minus f of 2 over 4 minus 2. And f of 4 is 3, f of 2 is 6, and then 4 minus 2. So it's going to be negative 3 over 2 is an estimate for f prime of 3. Again, if we want to do f prime, estimate f prime of 1, we're looking for x values to the right and left of 1, equidistant, as close as we possibly can get. So we're going to use the points, get our estimate here from f of 2 minus f of 0 over 2 minus 0. F of 2 is 6, f of 0 is 10, 2 minus 0. So that's going to be negative 4 over 2, or the estimate for f prime of 1 is negative 2. If we're going to estimate f prime of negative 1, we're going to use points where the x value is equidistant from negative 1, as close as we can get. So we have 0 and negative 2. So we're going to do f of 0 minus f of negative 2 over 0 minus negative 2, which equals f of 0 is 10, f of negative 2 is 7, and 0 minus negative 2 is positive 2. So that's going to give me 3 over 2 is the estimate for f prime of 1. And finally, if we're going to estimate f prime of negative 3, we're going to use points equidistant on either side of negative 3. We're given negative 2 and negative 4 for x values with points. So f prime of negative 3, our estimate is going to be f of negative 2 minus f of negative 4 over negative 2 minus negative 4. F of negative 2 is 7, f of negative 4 is 5, And -2 minus -4 makes -2 plus 4. So we get 2 over 2, or the estimate for f prime 3, given this table, is 1. That's how we estimate f prime for an x value in between two x values on the table. We're given data in a table. Let's look at a word problem here. We have Fred filling a large glass bowl with the bowl is marked to measure in cups from a pitcher. And he recorded the amount of water in the bowl at 2, 4, and 6 seconds while he was pouring. At A of t is a function that gives the amount of water in a bowl after t seconds. And we'll say it's a continuous differentiable function, right? Then we're going to estimate a prime of 3 and a prime of 5 if there were 2 cups of water in the bowl after 2 seconds. So now we look at that and let's think about what that means to us. After 2 seconds, t and a of t is the points we're looking, or that points we're looking for. So we have 2 seconds and we have 2 cups. And then we have 5 cups of water in the bowl after 4 seconds. So when t is 4, a of t is 5. And then we have 7 cups of water in a bowl after 6 seconds. So when t is 6, we have 7 cups of water. These are the points. And we're asked to estimate a prime of 3 and a prime of 5. And so our estimate for a prime of 3, we're going to use 2 points equidistant on either side of x equals 3. So we're going to do here f of 4 minus f of 2 over 2 minus 4, or sorry, 4 minus 2. And f of 4 is 5, f of 2 is 2, 4 minus 2. So we get 3 over 2 is our estimate for a prime of t. And since a is the amount of water in the bowl and t is the time in seconds, a prime is the rate of change in water with respect to time. So this would be 3/2 or 1.5 cups per second. A lot of times they're going to demand on the scoring rubrics that you have the correct units. So when you take the units for a prime are always going to be the units for a divided by the units of your independent variable. So the units of your dependent variable divided by the units of your independent variable. And so we're going to do a prime 5. We're going to use these 2 points because they're equidistant. 6 and 4 equidistant from 5 at around 5. And so we're going to do f of 6 minus f of 4 over 6 minus 4, which is going to be 7 minus 5 over 2. 2 over 2, which is 1 cup per second. Whoops. When we're given these scenarios, we're often going to have to use the correct units. And just remember that a prime, if a is the amount of water at time t, then a prime is the rate of change in the water at times t. So that's going to be in cups per second. Now we're going to we are given these equations, and we're asked to evaluate f prime of 4, estimate f prime of 4, and this one we're asked to estimate g prime of 5. Now for these, you don't know how to do this yet, algebraically or analytically, so we're going to do them with technology. Now, your calculator has a new operating system. The one on my computer does not. But we can still take the derivative of a function at a point. If we enter that function in our y equals, so I've entered this cosine x minus cosecant x, and remember your calculator doesn't have a cosecant button, but you can get cosecant is defined as 1 over sine. So it's not sine -1, that's sine inverse or arc sine. But you have to enter, if you're going to enter cosecant in, you have to enter it as 1 over sine x. So I've entered in y1 cosine x minus 1 over sine x. And in y2, we're going to put this other one here. Well, let's go ahead and put it in there now. Thought I did that already to save time, but I evidently forgot. So x cubed minus cosine x plus e to the x. Okay, so right now we're going to do this. We have y1 as f of x and y2 as g of x in the calculator. That's important because I want to show you how to use your y var or your y variables in your calculator to do this. Now, when you use your calculator and you do math 8, that's going to be your nDeriv. If you can't remember math 8, then just hit math and scroll down till you see nDeriv. That's a numeric derivative. This is what shows in my calculator with the old operating system. What's going to show in your calculator with the new operating system is when you type in that nDeriv, it's going to show d, and then d with a box. And then here you're going to have something, and you're going to have, sorry, not that line here, and it's going to say a variable, place for a variable you're going to put there. Oh, your variable. It's going to fill that variable in. And then you're going to have an equal sign because you're going to put what number you want this to evaluate. I'll show you what happens here. The first thing you're going to enter in there is the variable you want to take the derivative with respect to, x. And when you do that, it's automatically going to fill in this box. And then you're going to put in here. Now, since I have y1, what we want is f of x in here. But I have the calculator, remember, is stored as y1. So what I'm going to do to get that, I'm going to go to yvars, hit vars, yvars, function, and then enter on y1. And that's going to put f of x in this for me. So what you'll see when you do this on your calculator, this will show up as y1. But remember, you got to put it where you have the right function stored. That's what you'll type in your calculator. I'm going to show you how to do it on this old operating system because I just don't have a calculator I can show it to you. So y1, I've got to type in next the variable that I'm integrating with respect to, and then I want this, oops, I don't know why we put 1 there. This is x equals pi over 4, what we're evaluating at. Pi divided by 4. So what I've done here is the equivalent in your operating system of you putting a pi over 4 right here. So this is what you would enter in your calculator. The derivative of y1, if you have f of x stored as y1 in your calculator, and you have x is the variable we're integrating with respect to, it'll automatically fill in this x, and you tell it where you want it to evaluate the derivative at. And then it's going to give us the value. When I pull the calculator back up and tell it to go, then the estimated derivative there, the estimate for the derivative is 0.707. And we don't have units here, so we want to put units there. But if we did have units that represented, we would have the independent variable, or so the dependent variable over the independent variable of the units. So let's go ahead and do g of x also. And again, when you pull up the nDeriv or the numeric derivative or math 8, it's going to show you this. And we are going to enter an x here. It's automatically going to fill in the x when you do that. Now I have g of x and y2 in my calculator, so I'm going to go over and do y2, and then I want the derivative at 5, so I'm going to plug it in like that. I have the old operating system, so I'm going to do math 8. I've got to type in the function first in mine, which is y2, and then the variable that I integrate with respect to is x, and then the x value I want to take the derivative at. That's the equivalent of what we did here in your new operating system. Now to enter, it says the derivative of g of x, or g prime of 5 at x equals 5, is 222.454. 222.454. And that's how we calculate derivatives or estimate derivatives at a point from tables, graphs, word problems, and equations.